So today we're going to go over the answers for the odds on the Chapter 10 test review. So number 1, you're asked to find the inverse of each function. So the first thing you want to do is change the function of x to y equals, and then just rewrite the right side of the equation. Once you've done that, you're going to switch the x and the y. So this is going to be x equals -2 minus 1/2 y. And then you want to solve for y by doing inverse operations. So you want to add 2 to both sides. You're going to get x plus 2 equals the -1/2 y. So the inverse operation of y being multiplied by -1/2 is to multiply by -2 over 1, or just multiplying by -2. So on the left, we're going to distribute. That'll give us -2x minus 4. Over here, these will cancel, and we're just left with y. So now we have the inverse. When you go to rewrite the final answer, you're just going to say the inverse function of x is equal to -2x minus 4. Should that be plus? No. Okay. All right. Number 3. We're just going to simplify k squared times 3k squared. So I know there's a 1 right there that I can't see. I multiply the 1 and the 3. That gets me 3. Then I take the exponents and I add them. So that's going to be k to the 4th power. Number 5. Your answer should contain only positive exponents. So right now there's a negative exponent in the denominator. So I'm going to move that y squared up to the numerator, or the y to the -2nd up to the numerator, and make it positive y squared. That's going to leave me with 2/3. Y to the 1st and y to the 2nd is going to get us y to the 3rd. There's an x to the 4th. And then the only thing left in the denominator is 3. Number 7, we're going to rewrite the equation in exponential form. So you're going to simply take this base of 6, write it to the exponent of 2. That's going to equal the answer of 36. Number 9. Now we're going to write each equation in logarithmic form. So this is going to become log base 2 of the answer 32. And the power of 5 goes over here. Please make sure you write how to go back and forth between those on your note card. All right. Number 11, we're going to expand that log. And since there's multiplication right here and right here, the operation is plus. So this is going to become log base 10 of 5 plus log base 10 of 12 plus log base 10 of 11. That's all you need to do. All right, so for number 13, first thing you want to do is you want to rewrite this second and third term with 1/3 as their coefficients. So this is 1/3 log base 8 of A plus 1/3 log base 8 of B. And the first term, just leave it as log base 8 of C. These coefficients out here come up to be the exponent, 1/3. Same thing here, 1/3. And that 1/3 becomes the root when we go to condense it. So we're going to end up with log base 8, because they all have that log base 8. And then it's going to be C, because we don't need to do anything with that one, times the 3rd root of both A and B under that radical. All right? And to the top of the next page, number 15. So we've got some fancy notation, ln, which can be read as natural log, but it just means log base 10 of -3m. Set that equal to log base 10 of 4 minus 2m. And then since this side has log base 10 and this side has log base 10, then these two items can just be set equal to each other. So if we have negative 3m equals 4 minus 2m, we'll just add 2m to both sides. This becomes negative m equals 4. Multiply both sides by negative 1. So positive m is going to be equal to positive 4. No, negative 4. That should be negative. M equals negative 4. Don't mess up your signs. All right. Number 17 says use a calculator to approximate each to the nearest hundredth. So for number 17, it's already written in log base 10 of 1.9. So the calculator will do that for you because the calculator likes log base 10. But let's say it was a different one. You would just do the change of base formula. So you would say log of 1.9 divided by log base 10 of 10. And you would just type it into the calculator. So you'd say, hit the log button of 1.9, divide it by the log of 10, hit the equal sign, and you're going to get 0.278, but there's a 7 next to it, so we're going to round it. So it ends up being 0.279. Number 19, this is clearly expanded, so the first thing we're going to do is we're going to condense the left side because they're both log base 7. I can rewrite it as log base 7. And then, since there's an addition sign right here, that means we're going to multiply negative 4x times 9. That's going to be equal to 1. And to simplify in the parentheses right here, we get negative 36x. So log base 7 of negative 36x is equal to 1. Then I'm going to change that to exponential form because 7 to the first power is negative 36x. Divide both sides by negative 36. And so x is just going to be equal to negative 7 over 36. All right. Number 21, same thing. We're going to condense the left side. These are both log base 9. So our condense is going to be log base 9. Adding again, so we're going to multiply the 4 times the x, which just gets us 4x. Set that equal to 2. I can rewrite that in exponential form. So I'm going to say 9 squared equals 4x. 9 squared I know is 81, so 4x equals 81. Divide both sides by 4. And so x is equal to 81 over 4. Number 23. I'm going to just change this from exponential form to log form because I can't see anything else to do with it and just see what happens. So I'm going to rewrite it as log base 6 of 216 is equal to 2r. And then I know the calculator can't do this, so I'm going to do change of base. So this is going to be log base 10 of 216 over log base 10 of 6. All that's going to be equal to 2r. So on the calculator, we're going to type in log base 10, 216, divide that by log base 10 of 6, hit the equal sign, you get 3. But you also have this 2 over here, so we need to divide this by 2. So that means that r is going to be equal to 1.5. If you wanted to write that as 3 halves, you can do that as well. Either way is fine. All right, now we're getting into some review problems. So number 25 is clearly absolute value. So the first thing you want to do is isolate that absolute value by itself. So you're going to add 1 to both sides. which leaves you with the absolute value of negative 8v minus 1 equals 23. You separate this into two equations. The first one being negative 8v minus 1 equals 23, and the second one being negative 8v minus 1 equals negative 23. Solve them each separately. So the one on the left, you want to add 1 to both sides. Negative 8v equals 24. Divide both sides by negative 8. And you get v equals negative 3. Same steps over here, add the 1. So negative 8v is equal to negative 22. This one, when you divide by negative 8, you get a fraction. So v is going to be equal to 22 over 8, which reduces to 11 over 4. Number 27, we want to solve each equation by factoring. So on this one, we're going to get the factors first and then solve them. I know to get k squared, I need to multiply k times k. And then to get 35, I need to multiply two numbers that also need to add up to get negative 12, which means they're both going to be negative, because a negative times a negative is a positive, and a negative plus a negative is a negative. And I can do it in my head, it's 5 and 7. And then we just set each of them equal to 0, ends up being the opposite of 5, which is opposite of negative 5, which is positive 5, same thing here. So k is either going to be equal to 5 or positive 7. And then the last one on page 2, we just want to write this in slope-intercept form, which is y equals mx plus b. So we need to plug in the y-intercept for b and the slope for m. So let's start with the y-intercept, which is clearly here at negative 2. And then we need to count the slope. So from here until the next intersection, looks like here, it's clearly positive, right? And we're going up 1, 2 over 1, 2, 3, 4, 5. So 2/5 x, and that's what y will be equal to. Thanks for watching.